Okay. So 8b10, we're differentiating. First two examples. Okay, so example 1, log base 16 of 32 equals x. I'm going to pick on my smallest group right now. So you guys, what did you do first? Okay, wait. Did you put 16x or did you put 16 to the power of x? 16 to the power of x. Okay, so the reason why I want to clarify is just because sometimes, and I do see it, if you write 16x or if you write your exponent, your power of x really big, you think it's 16x, but something to an exponent is definitely different than something being multiplied, right? So just wanted to clarify. So 16 to the power of x equals 32, and then somebody else, what did you do next? So not Marissa.
16 more by 30. No, wait. 16 times 2 is 32.
Okay, so you divided both sides by 16?
Yeah.
Okay, but this is in the exponent, so can we do that?
So wait, is it? Hold on. I got this.
Okay, so Marissa said, don't we need to get the same bases? What would the base be? 2. Okay, guys, so 16 is 2 to the what? 4x, and then 32 is 2 to the 5th. So now that I have the same base, what can I do, Justin?
4x equals 5.
Okay, so 4x equals 5. And then, Melissa, what would I do next?
You divide 4 by 5.
Is it okay that I got a fraction?
Yeah.
Totally okay. Leave it as 5 over 4. Don't write 1 and a fourth. Okay, so leave it as x equals 5 over 4. Okay, thumbs up if you got that correct. Fabulous. Okay, so let's look at number 2. And I was helping some groups over here, so I'm going to pick on you guys because I know that you already got some help on it. So, what did you girls do first?
We condensed it, so it would be log base 3 of 4 squared.
Okay, so they condensed it to log base 3 of 4 squared plus log base 3 of 3x equals 2, and then what? Okay, so this is going to be 4 squared gave us 16 times 3x gives us what on the inside? 48x equals 2. And then I'm going to say what you guys asked me because I have a feeling that a lot of people did this. How many people then dropped the log? Anybody? Okay. Why can I not drop the log, Kelsey? Well, you have a log on the left-hand side, but is there a log on the right-hand side? So it's just like exponents. So in the previous problem, where we had to get the same bases before we could drop the bases, it's the same thing here. You have to have the same base. This one has a base of log base 3. This one's just a 2, so we can't drop the log. What can you do? Kashia, what'd you do next? Okay, so you guys got that. So look at this problem. In number 1, I have log base 16 of 32 equals x. X technically is a number, right? We just don't know what it is. And we rewrote it as an exponent. This one I have a log on the left and just a number on the right. So can I rewrite this as an exponent? 3 to the power of 2 equals 48x. Does this look like something we can solve? What is 3 to the power of 2, everybody? 9. So 9 equals 48x. And then what would we do? Divide by 48. Is it okay that I got a fraction? Yes. What does this fraction reduce? 9 over 48. 3 over 16, yeah. 3 goes into 9 3 times, and 3 goes into 48 16 times. So it reduces to x equals 3 over 16. So, what I want you guys to make sure that you are aware of. If you have a log on each side, you can drop the bases. Okay, that's just like in exponents. If you have only one log on one side, you have to rewrite it as an exponent. Okay, so log on each side, after you condense them, you can drop them. If you have a log on one side but not on the other, you have to rewrite it as an exponent. That's the only way you can solve. So you have to get that log out of there. Okay? Okay, I'm going to give you 2 more. Don't ask me why number 4 is written so much bigger than number 3. I have no idea. so number 3, natural log of x minus natural log of 5 equals 3. Really quickly before we get started, natural log is the same as log base what? Base e. Log by itself is log base 10. Okay, so natural log is the same as log base e. So use that in here. And then number 4, log of 25 plus log of 4 equals x. So those are base 10. Okay? Okay, so number 3 was natural log of x minus natural log of 5 equals 3. What did you girls do first?
We used the quotient rule.
Okay, so they used the quotient rule because it's subtraction. So we're condensing the left-hand side. So that's ln of x over 5. Please put it in parentheses so that you know it all goes together, equals 3. Okay, so I told you guys that ln, or natural log, is log base e. So then what did you do? Somebody else. You guys did it right. What'd you do?
No. It would be e, so that there's
Mm-hmm.
Good.
Good. Okay. So you can if you want to, you can rewrite ln as log base e, so you could replace it. I saw somebody over here do that. That's totally acceptable. If sometimes what I even do is right where it says ln, I just put an e right there so I remember that it's a base of e. And then when I come around and rewrite as an exponent, it would be base e to the third equals x over 5. Now your instructions, I'm going to go up for a second, say solve for x. Do I have x totally by itself yet? No. So Jessica, what did you do next?
Multiply by 5.
Mm-hmm.
Both sides.
Yep. So you multiply 5 by both sides because those 5s will reduce. So we end up with x equals 5e cubed. That is a perfectly acceptable answer. Remember in geometry last year when you guys were doing like area of a circle or volume of a cylinder and you were allowed to have pi in your answer? This is the exact same idea. E is a number just like pi. It's 2.71, goes on forever and ever. It's not a variable, but to get the most exact answer, we leave it in terms of e. So if you ever get e as part of your answer, leave it as e, but don't solve for it because it's not a variable. It actually has a value, okay? E is about approximately 2.71, okay? So you could plug it in, but I don't want you to. I want you to leave it as an e, okay? Okay, so let's look at number 4. Log 25 plus log 4 equals x. Group in the back. Allison, your group. What did you girls do first? Somebody, anybody, I don't care.
We condensed the left.
Okay, so which rule did you use, Alexis? The product rule. So this would be log of 25 times 4 equals x. So that's log of 100 equals x. And then somebody else, what did you do?
There's 10 by the log.
Okay. So log by itself is actually a base of 10.
So it's 10 equals 100.
Okay, and just to clarify, 10x or 10 to the power x? To the power x. Okay, so 10 to the power of x equals 100. And then somebody else, what did you do next? Okay, so that's 10 squared. And then, Allison, what did you do? Drop the bases, and x equals 2. Did anybody recognize that this was also a special rule, just out of curiosity? Okay, so another method that you could have done. You could have rewritten this as log base 10 of 10 squared equals x, because I have the same bases, so what happens? You can drop them, so x equals 2. Exact same answer. If you're unsure about your special rules, go all of the way through the problems because you will get the exact same answer. Okay, the process is exactly the same. Okay? Questions so far? Okay, hopefully nobody tried to drop the logs on 4 or 3 because they didn't have one on the other side. So let me give you one where we do. Okay, so 5 and 6. Number 5 is similar to what you had in homework for today. So number 5 is log base 2 of x plus 2 log base 2 of 5 equals log base 2 of 100. And number 6, log base 6 of x plus log base 6 of x minus 5 equals 2. Really quick, guys, what is the difference between 5 and 6? Just in looking at them.
What of them is the x minus 5?
One of them has an x minus 5 in it, in parentheses. Anything else that you notice? Yeah, number 5 has a log on the right, and number 6 does not. So do you think you can use the same method to solving these? Okay. So get working on both of those. So number 5, Ryan's group. Who's going to go first? Okay, what was your first step?
Alright, so first we took the 2 in front of log of 5 and we moved it up as an exponent of 5, so it's 45.
Okay, so just to repeat, so everyone can hear, they took the 2 and made it an exponent of 5. So that's going to be log base 2 of x plus log base 2 of 5 squared, which is 25, equals log base 2 of 100. Everybody good so far? Okay, somebody else, what did you do next?
And then you condense the,
Okay.
on the left, yeah.
Okay, so you condense on the left. What rule is this? Multiplication. So that's going to be 25x, correct? Equals log base 2 of 100. And then we can drop the logs. Why? Because there's one on each side. So you can drop the logs because there's one on each side. So 25x equals 100, and then what did you do last? Divide everything by 25. So Megan, what did you get as your answer? 4. Who got that correct? Fabulous. Okay, so number 6, I was coming around to all of you individually, and all of you got to a certain point and then stopped. But it's only because I think that we were connecting 2 ideas now into one problem. So let's look at number 6. Log base 6 of x plus log base 6 of x minus 5 equals 2. Morgan's group is up, so somebody, what'd you do first? Okay. So that would give us what? Okay, so it's multiplication. So log base 6 of x times x minus 5 equals 2. Somebody else, what'd you do next?
You would want to convert your x into, or distribute the x.
Okay, so we're going to distribute the x. So that's log base 6. I'm going to keep it in parentheses, guys, so that you know that it's all still together. X squared minus 5x, yes? Okay, next step. Oh, thank you. What did you do next? I have a log on the left and nothing on the right, so what do I have to do? Some people are getting it. Some people are saying that we have to rewrite it as an exponent. So Genesis, what would the exponent be? The exponent is 2. What's the base? Okay, so 6 squared equals what? Okay, everybody, what is 6 squared? 36. So we would get 36 equals x squared minus 5x. And then, Brittany, what did you guys do next? Okay, so that would give us 0 equals x squared minus 5x minus 36. And everybody, have we done this before? Yes. What method of factoring is this? Okay, what two numbers multiply to negative 36 and add up to negative 5? 4 and negative 9. So this is going to be x plus 4 times x minus 9. Thank you, guys. And so if I set each one equal to 0 and x minus 9 equal to 0, what would my two answers be for x? -4 and +9. Now, it is okay to have two answers. It's very, very possible that we can get two possibilities for x. However, if you guys look back up at the original problem, part of it is log base 6 of x. What does x have to be? Positive, so x has to be greater than 0, and it also cannot equal what? 1. So can I eliminate one of my answers? Yeah, the -4. So my only answer possibility here is x equals 9. Okay. Okay, so we have natural log of x plus natural log of 4 equals natural log of 24. Last group, what did you do first?
We have to
Condense.
on the left side,
On the left side, what rule did you use?
product.
Product. So that's going to be natural log of 4x equals natural log of 24. Okay, somebody else, then what'd you do? Drop the bases. So we can do that because we have natural log on both sides. So that is 4x equals 24, and then last step.
Divide the 4 into 24.
So Jasmine, what'd you get as your answer? X equals 6. How many of you got that correct? Fabulous. Okay, so what I really want you guys to get out of this, because this is basically everything we did from the entire unit and then all mixed together. If you have a log on one side but no log on the other, you have to rewrite as an exponent to solve. If you have log on both sides, condense, and then you can drop the logs. Okay, that was the biggest thing. Okay, so I don't want you guys dropping bases where you can't. Okay, so make sure that you have log on each side before you do that. Okay? Okay.